Sample exam for chapters 5 and 6. I want to determine the cotangent of 210 degrees. Well, 210 degrees is in the third quadrant. The reference angle here is 30 degrees. And so, let me draw a triangle. A 30, 60, 90 triangle. Cotangent is adjacent over opposite. These are both going to be negative since we're in the third quadrant. Negative over negative is positive. Let me do problem number 2. Cosine 7 pi over 4 so the angle 7 pi over 4, 1, 2, 3, 4, 5, 6, 7 pi over 4, oops, is here in the fourth quadrant. The reference angle is pi over 4. Cosine will be positive in the fourth quadrant. We draw a triangle. And so a 45, 90 degree triangle. And so, or actually let's write it this way. Red 2, red 2, 2. And so cosine is going to be positive. In the fourth quadrant. And so it is adjacent over hypotenuse, red 2 over 2. Let me do problem number 3. Cosine, inverse sine of 4/5. So let theta be such that sine of theta is 4/5 opposite over adjacent. And so cosine of theta is adjacent over hypotenuse, 3 over 5. Let me do problem number 4. Tangent, inverse sine, 12 over 13. So let me draw a triangle, a right triangle. So I want theta such that sine of theta is 12 over 13, opposite over hypotenuse. And so we have a 5, 12, 13 triangle. So I want to determine tangent sine inverse 12 over 13. So this is the same as tangent of theta, which is opposite over adjacent, 12 over 5. Let me do problem number 5. Cosecant. Seven pi over 6. Okay. And so let's determine your quadrant of the angle. So 6 pi over 6, 7 pi over 6. So your reference angle is pi over 6. Let me draw a triangle. So a 30, 60, 90 triangle. And so sine is going to be negative. Cosecant will be negative in the third quadrant. Cosecant is just hypotenuse over opposite. So your answer is negative 2. Okay. Let me do problem number 6. Okay. Sine 4 pi over 3. Oh, actually, we have the triangle right there. And so, again, you're in the third quadrant. So 4 pi over 3. So your reference angle is pi over 3. And so looking at the above triangle, sine is going to be negative in the third quadrant. And so sine of pi over 3 opposites over hypotenuse, read 3 over 2. And that is your answer. Problem number 7. Sine inverse, read 3 over 2. Okay. Well, this is equal to theta such that the sine of theta is rad 3 over 2. So opposite over hypotenuse, And well, this is a 30, 60, 90 triangle. So theta, so sine inverse of rad 3 over 2 is just theta. But in this case, theta is pi over 3. It's a 30, 60, 90 triangle. Oops. That was problem number 7. 8. Tangent inverse of negative rad 3. Well, actually I can use this triangle here. And so, rad 3, so I want to find theta. Such that tangent of theta is negative rad 3. Okay, so let's use the above triangle. So I just want to find theta here. Well, first off, tangent is going to be negative in either the second or fourth quadrant. And so we want it to be negative in the fourth quadrant. Tangent of pi over 3, well, of pi over 3 is rad 3 over 1. And so this is just pi over 3. And we want pi over 3 to be in the fourth quadrant. So it's a negative pi over 3. And that's your answer. 9. Tangent, sine inverse of 1/2. So you want to determine theta such that sine of theta is 1/2. Well, again, if I look at this, well, maybe I'll draw this up here. Okay, let me just check something. Can you, here, wait. Let's see. Okay. Turn it back on, just to be sure. Okay, it can, yeah, it's still going here. Okay, so I have here that the sine of theta is 1/2. And so this is a 30, 60, 90 triangle. So this is equal to, so tangent inverse, tangent. Oh, and then I want to find tangent. And so tangent, oh, I don't even need that then. So tangent sine inverse of 1/2 is the same as tangent of theta, but tangent of theta is, well, opposite over hypotenuse. So 1 over rad 3. I guess I'll rationalize the denominator. And so multiplying by rad 3 over rad 3, I get rad 3 over 3. Let me do problem number 10. Cosine sine inverse rad 3 over 2. So again, you want to find theta such that sine theta is rad 3 over 2. So it's again the same triangle. And so sine is opposites over hypotenuse. And so let's do the cosine of sine inverse rad 3 over 2. So this is cosine of theta. Oops, and this is a 1 here. And so cosine is opposite, adjacent over hypotenuse. So 1/2. Let me do problem number 11. Tangent. Cosine inverse 1/2. So define theta such that cosine theta is 1/2, which is the above triangle actually. So you have a rad 3 also. So let's find the tangent of cosine inverse of 1/2, which is the tangent of theta, which is opposite over adjacent. And so this is equal to rad 3. Solve the triangle. So let's draw some triangle here. So 50 degrees. This is A. So this is A, which and angle B is 68 degrees. And length C is 230. Okay, so let's figure out this triangle. So first off, that C looks like my other C. The sum of the angles of your triangle is going to be, everything's in degrees, so 180 degrees. So I have 50 plus 68 plus C is 180, and so C, the measure of angle C, is 62 degrees. Okay, good. Now let's figure out the others. I can either use law of sines or law of cosines. I'll use the law of sines. might as well. And so I have that the sine of b over the length of b is equal to the sine of, oh, let's say c, which is 62 degrees, over 230, over the length of c. Okay, so from there, I get b is equal to 230 times the sine of 68 degrees over the sine of 62 degrees. Okay? I guess I'll give you an approximate number for this, just to see what order of magnitude that is. So let's see, 68 degrees, 62 times 230, approximately 241.523153, approximately. Okay. So that I have everything but A. Okay, so let's figure out A. So the sine of A, 50, over A is equal to the sine of B, which is 68 degrees, over the length of B, which is 230, over sine is 68 degrees, sine is 62 degrees, and so sine of 50 degrees over A is equal to the sine of 62 degrees over 230. Oh, why didn't I do that? Why didn't I do B? Why did I do C, which I knew was 62 degrees? I should do that instead, so I don't need that extra line. Obviously, it gives you the same answer. And so it's the sine of C, which is 62 degrees, over C, length of C, which is 230. Okay, so that says that A is equal to 230 times the sine of 50 over the sine of 62. Okay, which is approximately 199.5477686. Okay, so I have the following. A equals 230 sine 50 over sine 62 degrees. B, 230 sine 68 over sine 62. C is 230 So those are the lengths. Then I have angle A has a measure of 50. Angle B, 68. Angle C, 62. And let me just check if I'm correct. 50, 68, 50, 68, and then 62. Yeah. Okay, so that is my triangle. Okay. Let me do problem number 13. 13. Okay, so A maybe I'll call that A. B, C. So A, problem 13, is 28. B is 15. C is 53. Again, you can use law of sines or law of cosines. In this case, actually, law of cosines will probably be easier. Well, law of sines will give you everything in terms of... I think law of cosine is still easier. Okay, so call this C. So C squared is equal to A squared plus B squared minus 2AB cosine C. Okay, and so I have C squared is equal to 28 squared plus 15 squared minus 2 times 28 times 15 times the cosine of 53 degrees. Okay, and so let me multiply that out. So C squared is equal to 1009 minus 840 cosine 53 degrees. And so I have C is equal to the square root of 1009 minus 840 cosine of 53 degrees. Okay. So now let's do, so that's what C is equal to. Let's figure out, let's say A. So I'll just use law of sines for that. So I have the sine. Oh, well. I have here the sine of A over the length of A, 28, is equal to the sine of C over the length of C, which is 1009 minus 840 cosine of 53 degrees. And so I have that the sine of A is equal to 28 sine 53 degrees over the square root of 1009 minus 840 cosine of 53 degrees. And so A is equal to the inverse sine of 28 sine 53 degrees square root 1009 minus 840 cosine 53 degrees. Okay, so that's A. To figure out B, I know that the sum of the angles of a triangle is 180 degrees, and so B is equal to, well, 180 minus 53, 127, minus the inverse sine of 28 sine 53, the length, the measure of angle A, over the square root of 1009 minus 840 cosine of 53 degrees. Okay, that's B. Oh, that's everything. Okay, so let's write everything down. Oh, and I should give approximate answers just to see what this is approximately. Okay, so let's figure out what that is approximately. 1009 minus 840 times cosine of 53 degrees. Take the square root of that. So this is approximately 22.43825.707. Okay. Let's see. Angle A is 28 times sine of 53 degrees, and then take arc sine. That was C. Okay. C was 53. Let me just see something for 1 second. Wait. What in the world? Oh, I put part of 13 and I mixed up two problems at the very end. I just noticed that. Problem 13, I put in the wrong numbers. 2815, that's 110. And that's angle A is 110. Okay. Well, that's very disappointing. Okay, so I was I had the wrong numbers. So, unfortunately, obviously it's a incorrect answer because the numbers are all wrong. Okay. Okay, so let me just check that I put down the right numbers in here. So A has this is problem 13. And I did problem 12 before. Okay, let's see problem 12 has the right numbers. 50, 68, yes, those are all correct. And 230 for C. Okay, so those were correct. Problem C, problem 13. So now for problem 13, it is 28 for A, 15 for B, and 110 for A. Okay. So let's use the law of sines for this one, because that's okay. So I have the sine of 110 degrees over 28 is equal to, let's say, the sine of B over 15. Okay, so from there, I get the sine of B is equal to 15 over 28 sine of 110 degrees. And so the measure of angle B is the inverse sine of 15 over 28 sine of 110 degrees. Okay. Which is approximately, let me find the approximate answer for that. And so it is 15 over sine of 110 degrees. Take the inverse sine, approximately 30.22564662 degrees. Okay, so now let's figure out, so I have A and B, let's figure out C. So measure of angle A plus B plus C is equal to 180 degrees. And so 110 plus B plus C is 180. And so the measure of angle C is going to be 70 minus inverse sine 15 over 28 sine of 110 degrees. Okay, which is approximately well, it's going to be approximately 40. So, of course, I didn't save that, did I? 15 over 28. 39.774 35338 degrees. Okay. B, and did I find C yet? No, I didn't find the C. Okay. And so, that's the only way to do it. Do law of cosines to get it, but I'll just do law of sines. Okay, so I have sine of 110 over 28. So the sine of A over the length of A, 110 over 28, is equal to the sine of C over the length of measures of the side C. And so all that stuff. And so C is equal to 28 times sine (70) minus sine inverse 15 over 28 sine of 110 degrees over sine of 110 degrees. So this is approximately 1 second, because that's wrong. Okay, 15 over 28 times okay. So take the sine of that divided by sine of 110 multiplied by 28. I get approximately 19.06308.538. Okay. So I think that's everything. So let me write down the triangle. So A is 28. B is 15. C 28 sine 70 minus arc sine 15 over 28 sine 110 over sine 110. Oops. Okay, now angle A. Angle A is 110. Angle B is the sine inverse. (15/28) sine of 110 degrees. And then angle C is that thing. 70 minus inverse sine 15/28 sine of 110 degrees. Okay, so that's your triangle. Okay, good. Any questions about that? Okay. That was 13. Let me do 14. That was 13. So let me do problem number 14. A, this is A, B, C, let's say. A is 3, B is 4, C is 53 degrees. Okay. Law of cosines looks easier. So this is A, B, this is C. So I have C squared is equal to A squared plus B squared minus 2AB cosines of C. And so C squared is equal to A squared plus B squared minus 2AC cosine of 53 degrees. 9 plus 16, 25 minus 24 cosine of 53 degrees. And so C squared, so C is equal to, obviously we just want the positive square root, 25 minus 24 cosine of 53 degrees, which is approximately 3.24 906 7473. Okay. Okay, let's figure out an angle. Let's say angle A is the sine of angle C over the length of C and let's say the sine of angle A over the length of A. And so I get that the sine of A is equal to 3 sine of 53 over the square root of 25 minus 24 cosine of 53. And so angle A has a measure of arc sine 3 sine 53 degrees over the square root of 25 minus 24, cosine of 53 degrees. And this is approximately, let's see, .51155724 degrees. Okay. So I have A is 3, B is 4, C is rad 25 minus 24 cosine of 53 degrees. Angle A, here's angle A, is inverse sine 3 sine 53 degrees over rad 25 minus 24 cosine of 53 degrees. Angle B, I didn't find angle B. Well, we'll just, okay, angle C is 53. The sum of these must be 180. And so 180 minus 53 is 127. I didn't write that down. Minus angle A, sine inverse 3 sine 53 over the square root 25 minus 25 cosine 53 degrees. Okay, so if I add those up, I'll just get 180. And that is my triangle. Oh, and of course, well, angle B is 127 minus that. It's approximately 79.48. Angle B is approximately 79.48844,276. I forgot to, write that down. Okay, let me do problem number 15. Any questions about this? Okay, problem 15. Solve the triangle 15. A, B, C. Problem 15. A is 20. B is 25. C is 22. Okay. So I guess I'll just have to use law of cosines first to figure out these angles. So I don't care. Maybe I'll do C first. C squared equals A squared plus B squared minus 2AB cosine of the measure of angle C. And so 22 squared is equal to 20 squared plus 25 squared minus 2 times 20 times 25 times cosine of C. So 484, I believe. Yeah, 484 is equal to 400 plus 625 minus 1,000 cosine C. Okay. And so I get, well, 484 is equal to 1,025 minus 1,000 cosine C. And so 1,000 cosine C is equal to 541. And so C, cosine C, is equal to, well, maybe I'll just write it that way. But of course it's not approximate. This is the exact answer. And so I have that C is equal to cosine inverse. I'll just write 541 over 1,000. Okay, which is approximately 57.24826.084 degrees. Okay. So, I guess I'll use law of sines for the other ones. I have the sine of A over 20 is equal to the sine of cosine inverse (541 over 1,000) divided by, this is C, right? This is C, 22. (541, 1,000). We can figure out what the sine is of that. So, oh, of course I just erased it. I want theta such that cosine of theta is 541 over 1,000. That's 541 over 1,000. And so a squared plus b squared equals c squared. So 1,000 squared minus 541 squared. 707,319 is the square of side B. Okay, so I have that the sine of a over 20 is equal to the sine, which is opposite over the sine of theta, which is opposite 707,319 over hypotenuse divided by 22. And so I have that the sine of the length of measure A is 20 times this, which is actually 22 thousand. Of course, I can divide by 20. $1,100. Okay. And so I have that A is equal to sine inverse radical 707,319 over 1,100. Approximately 49.868 39624 degrees, approximately. Okay, so let's see. I have A, I have C, and B is A plus B plus C is 180 degrees. Oh, none of these are nice. Okay, so A inverse sine thousand plus angle B plus angle C, oops, which was cosine inverse of 541 over 1,000 is 180. And so angle B is 180 minus arc sine rad 707,319 minus arc cosine 541 over 1,000. Okay, so let's So I'm done. So A is 20. B is 25. B is 25. C is 22. Okay. A is inverse sine rad 707,319 over 1,000. B is 180 minus inverse sine 707,319 over 1,000 minus cosine. Oh, I never said what that was approximately. Cosine inverse 541 over 1,000. And angle C, ABC, cosine inverse 541 over 1,000. So I gave approximate values for C, for A, but not for B. Okay, so this is approximately 180 minus, no, let's do this. So 707,319 divided by 1,000. Inverse sine 65. Wait. Let me just do this. That's 40. That's 50. 107. That's wrong. Okay, so let's do this again. I thought I hit something wrong. Okay. 707,319 divided by 1,000. Inverse sine. There, it looks better. $65.503,478.31 degrees. Okay, so let me just check. 65 plus one second, I'm sorry. 0.541 arc cosine. $707,319 square root divided by 1,000. Arc sine. Okay, wait 1 second. cosine, the sine of that. Now I'm getting a different answer. Oh, because I'm putting in the wrong number. Oh, you stupid. There was a typo there. It's divided by 1100. Yes. That's where the error came in. Okay, sorry about that. That's 1100. That's 1100. That's 1100. Okay, so now. No wonder I was getting the wrong answer there. Okay, so now try that again. 707,319 square root divided by 1100. Okay, good. Okay, so this is 72.88334292 degrees. Okay, good. So those are the approximate answers. Had a little bit error there. Okay, so this is your triangle. Okay, that was problem 15. Oh, that 1,000 is correct there, but the 1,000 is incorrect there. Okay, problem number 16. Find the area of a triangle with sides of length 7, 8, 9. So use Heron's formula. So S is 1/2 A plus B plus C. So let's figure out the semi-perimeter. First, 7 plus 8 plus 9. So let me do that on my calculator. 7 plus 8 plus 9. Divide by 2. Yep, good. Let me determine the area. 12. 12 minus 7. 12 minus 8. 12 minus 9. 12 times 5 times 4 times 3. 12 rad 5. Yep. So it's 12 rad 5 is your area. Okay, here, wait. 7, 8, 9. Let me do problem number 17. Hmm. Let me check something for 1 second. Hmm. I'm just checking something for 1 second. Hmm. Oh, I see. Okay. So let me give an approximate answer for this. $26.83281573. Okay, let me do problem 17. Uh-oh. That was problem 17. I did problem 17 first. Okay. That was 17. I just put down the numbers for problem 17. So so I did problem 17. I'll do problem 16 now. Okay. Okay. So 17 was A is 7, B is 8, C is 9. 16, however, A is 9, B is 12, C is 15. And so A is radical S minus A, S minus B, S minus C, where S is 1/2 A plus B plus C. And so this is equal to 1/2 9 plus 12 plus 15. So let me add that up. 9 plus 12 plus 15 divided by 2, 18. And so A is equal to square root of 18. 18 minus 9, 18 minus 12, 18 minus 15, 18 times 9, times 6, times 3. Oh, that looks like a nice number. And so 18 times 9 times 6 times 3, 2916, 54. So we already did 17. Okay. Any questions on that? Okay, 18. Let's guess the graph of minus sine x. So this is just going to be a reflection. So reflect the graph of y equaling sine x about the x-axis. Okay, so let's say that that's 1. Pi over 2 pi 3 pi over 2. I'll just go 2 pi over 2 pi 3 pi over 2 2 pi. Okay, so sine looks like this. Oh, okay. Something like that. Okay. Oh, I went down to 2 here, didn't I? Okay. That obviously went too far. Okay, there. So that's what sine looks like. And now let's reflect. So this is the graph of y equals sine x. Let's reflect this about the x-axis. And so it should look something like so the black is the graph of minus sine x. Okay. 19. Cosine 2x. Okay, so this will just be where I'm going to compress. So this will be, now stretch the x-axis. So stretch x-axis. Let's compress the x-axis by a factor of 2 for y equals cosine. Since I'm multiplying by 2, I'm going to make it half as big. Maybe I'll say that that is 1. It'll be easier to draw it. Okay, so maybe I'll do So I'm going to do several, and let's say that's 1 and minus 1. Okay, so cosine, so let's draw the graph of y equals cosine. Oops. Let's draw it in red. And so cosine should look something like that. Something like this. Okay, not too horribly bad. Not great, but okay. So that's y equals cosine. Okay, and now let's compress this. I'm going to compress this. Squash the x-axis in by a factor of 2. So when I do that, now it's going to do pi over 4. Nah, I think I won't. I'll just... Okay. Okay, so now, not that those look even. So now the graph will look something like okay. And that's obviously not very, and neither is that one. These are not evenly spaced at all. Now that they're not evenly spaced, it's hard to tell where's what. Okay, there, there, there. So this is the graph of y equaling cosine of 2x. I've just sort of squashed it in. 20. Sketch a graph of f of x, y equaling no, it said here y equaling tangent 3x. Okay, so I'm going to compress my scale again. So compress, how do I say it, the x-axis by a factor of 3 for the graph of y equal tangent x. Okay, so let's draw the tangent. Oops. And I don't think I'm going to go very far with tangent. So let's just do pi over 2 minus pi over 2, 3 pi over 2 minus 3 pi over 2. Okay, so tangent should look something like this. So that's the graph of tangent. So let's compress the scale here by a factor of 3. So this is going to be at pi over 6. Well, maybe I'll put in this. It's going to be pi over 6. It's going to really squash it. And that's minus pi over 6. So I drew too big to get all. There'll be so many of these. Okay, so there's one there. And then there's another one here. That'll be pi over 3. And then this. And then the negative pi over. Okay. I just did. I'm going to make this much, my scale much smaller, because it just looks too compressed. Factor of 3 is just compressing it too much. I don't like that. Okay. So let me draw this. Sorry about that. And let's just do one cycle. I'm just going to do one cycle. Pi over 2 minus pi over 2. Okay. And so sine, well, I'm sort of exaggerating. Oops. I want it in red. So let's do this in red. I'm going to exaggerate because I want to compress this a lot. Okay, so this is the graph of y cotangent x. Okay, and then obviously you continue with this sort of thing. Okay, so let's compress this by a factor of 3. So if I do that, this is going to be pi over 6 pi over 3 maybe I should have done that in red. I should do these in red for the, because those are the asymptotes for this guy. Okay, so now let's do it in black. Okay, so now compressing it by a factor of 3, it looks like this. Okay, not as, put it halfway. Okay, oops. And so that's what it looks like. There. Yeah, so I had to make it really wide, otherwise you couldn't see anything. Any questions about that? Okay, 21. Sketch the graph of y equaling cosecant. again, you're going to compress the x-axis by a factor of 4 for the graph of y equaling cosecant x. Okay, so that's going to be compressed a lot. So I can only do just one at most of these. Okay, so pi and let's do minus pi. Okay, I'll put in some other things, so minus pi over 2. Okay, so and let's make this 1 here, I guess. Okay, so sine of 0 is 0. Sine of pi is 0. And sine of pi over 2 is 1. So cosecant is going to blow up at 0. Oops, I'm supposed to be doing this in red. And maybe I should really exaggerate how flat it is. So it looks like this. And like this. So this is y equaling cosecant. And now let's squash this in by a factor of 4. Okay, so now this is going to be pi over 4. Okay. So pi over 4, 3 pi over 4. Okay, so it's going to really look squashed. So it's going to look like this. Yeah, whatever. Like this. This. Really not like this. That looks better. The upper ones don't look so good. Like this. Like this. That's like this. Okay, so this is the graph of y equaling cosecant 4x. Okay. 22. The Greek mathematician Eratosthenes, 276 to 195 BC, measured the circumference of the earth. From the following observations, he noticed on a certain day the sun shone directly down a deep well in Syene. That's Aswan. At the same time, in Alexandria, 500 miles north, on the same meridian, the rays of the sun shone at an angle of 7.2 degrees to the zenith. Okay. (7.2 degrees). Uses information. Oh, and this is 500 miles north on the same meridian. Find the radius of the Earth. So let's do that. First, let's figure out what theta is. So it's 7.2 degrees, and there are pi radians in 180 degrees. So this is pi over 25. And so the arc length S is r theta. So 500 is equal to r times pi over 25. So r is equal to 25 times 500 over pi. So 12,500 over pi. So the radius of the Earth is 12,500 over pi miles. Approximately 3,978.873577 miles. Probably 4,000 is about as close as you can get. And you want to figure out the circumference, which is 2 pi times the radius. So the circumference of the Earth is 2 pi times 12,500 over pi, which is 25,000 miles. And so the circumference of the Earth, and that's pretty close, is 25,000 miles. Okay, let me do problem number 23. A truck so you have a truck here which wheels that have a diameter 48 inches. So this is 24 inches. This is 48 inches. It's traveling at 50 miles per hour. So it's going at 50 miles per hour. How many revolutions per minute? Okay, so let's figure out that. So let's figure out the distance. Well, s, the velocity, is the distance over the time. Okay. And this is the radius times the angle it's gone in a certain amount of time. Okay. Which is usually omega. Okay, so let's do that. So omega is equal to the velocity over the radius. Okay, so the velocity is 50 miles in 1 hour. But in 1 hour, there are 60 minutes. In 1 minute, there are 60 seconds. Okay. And now the radius is 1 over 24 inches. Oh, they'll give you the now there are, oh, there's too many of these. I have it in miles, and this is one to be in inches. There are 12 inches in 1 foot. There are 5,280 feet in 1 mile. And so this gives you the number of radians per unit per second. But there are 2 pi radians in 1 revolution. Okay, so now got to multiply all this together. Okay, notice, hopefully, miles, well, let's see, miles cancel with miles, feet cancel with feet, inches cancel with inches, minutes with minutes, hours to hours, and this was given in radians, so the radians cancel, and so now you get ooh. That's, ooh. So I did it wrong. Revolution in 2 pi radians. Because this was given in radians, so I got to cancel the radians. And so now that gives us revolutions per second. Okay, so multiply this out. 50. Well, let's at least do some cancellations, maybe. Well, no. I'll just multiply it out and then cancel. Reduce it at the end. No, it won't. Okay, that's a 5. That's a 6. 60, so 5280 divided by 60 is 88. So this divided by that is 88. And maybe I'll leave it at that. Okay, even though I can do a whole bunch more cancellations. So that becomes a 1. Okay, so I have 5 times 12. Obviously, that's 12s and 24s. I can't do that. Okay, let's divide the 12 and the 24 to get a 2. Okay, obviously I can still reduce some other things, but 5 times 88, 440. Oops. At least there'll be less cancellations to do. 5 times 88, and then 6 times 2 times pi is 24 pi. Okay, divide by 8. So 55 over 3 pi RPM. Revolutions per second. Oh, I wanted it per minute. I have revolutions per second. These go revolutions per second, so I have to multiply by 60. Okay, 1 second. These are revolutions per minute they wanted. So the radius is 24. Inches, sorry. 12 inches per foot. 5,280 feet per mile. And lastly, 1 revolution in 2 pi radians. Okay, I can fit that all there then. Because I want revolutions per minute. Okay, so this is equal to, divide that, so you get 2 let's just leave it like that. So I have 5 times 5280. Oh, that's a big number, times 5280. 20, oops. So 5 times 5,280 is 26,400 over 12 times 2, 24 pi. I can divide everything by 8. 33 over 3 pi. Okay, and so this is approximately, 350.14087 1408748 RPM. 1 second, one of my things went out, so I can't see the question. Let me look. Let me go into another computer to do the last two problems. Problems 24. Okay, here. Problem 24. Oh, okay, so problem 24 says a 20-foot ladder leans against the building so that, 72 degrees, sorry. Leans against the ladder so that the angle between the ground and ladder is 72 degrees. How high does the ladder reach on the building? Okay, so I have that the sine is opposite over hypotenuse. And so the height is 20 sine of 72 degrees. And so, feet. This is approximately 19.0211, 3033 feet. Okay, let me do problem 25. A man lying on a beach flies a kite. So here's the kite up here. Yeah, whatever. Okay, so there's the kite. Okay. He holds the ends of the kite string on the ground. He estimates the level of elevation to be 50 degrees. If the string is 450 feet long, oh, it's the same problem. How high is the kite above the ground? Okay, so the sine is the opposite over the hypotenuse. And so the height is 450 sine of 50 degrees. And this is in feet. And so if you plug that into your calculator, it is approximately 344.7199994 feet. Okay. Any questions about that? Any questions on any of the problems? Okay. If not,